Ever look at your favorite software application and wonder, how does this actually work under the hood? Well, today, we're going to figure that out by learning how to build a digital house out of Java code. We're going to take those dry, theoretical textbook concepts and transform them into a tangible blueprint for interactive software. So let's dive right into this explainer.
Here's our roadmap for today. First, what is a GUI? Second, we'll look at the Swing versus AWT toolkits. Third, the event-driven triad. Fourth, we'll go inside the MVC architecture. Fifth, the building blocks, Swing components. And finally, number 6, how to actually build your GUI. Let's jump in.
Section 1. What is a GUI? The blueprint.
So, according to our source material, a GUI, or Graphical User Interface, is a well-designed layout of interactive graphical components, and its entire purpose is to allow runtime user-program communication. Because think about it, without a GUI, you literally just have a silent machine computing ones and zeros in the dark. The GUI is that vital, expressive bridge between what the human needs and cold machine logic. But what makes a good GUI? The philosophy behind this is actually really interesting. Good design relies on a few core rules. First up, simplicity and respect. Basically, keep tasks uncomplicated for your user. Next is transparency. A great GUI hides all the messy internal mechanics of the computer. You always want to prioritize human needs over technical constraints, and maintain visibility by clearly showing the system status. It's really all about crafting a respectful interface that empowers the user rather than confusing them.
Moving on to Section 2, Swing versus AWT, the foundation.
Take a look at this underlying technical matrix running our interfaces. It is a fantastic reminder that no matter how beautiful your digital house looks on the outside, a solid, reliable interface relies entirely on having the right technical framework running under the hood. And in Java, you've got a major choice to make regarding that foundation.
That choice really comes down to AWT versus Swing. AWT is the older precursor toolkit. Its components are what programmers call heavyweight because they're tied directly to your local operating system's graphics. And unfortunately, that leads to a pretty inconsistent look depending on the machine your user is running it on. On the flip side, we have Swing. Swing is modern and its components are lightweight. They're written in pure Java, which means they offer a highly customizable, consistent look and feel across any platform. Plus, you get advanced event handling. That cross-platform consistency is exactly why modern developers almost always choose Swing to pour their foundation.
Section 3. The event-driven triad, floor plan and wiring. All right, we have officially reached the technical heart of our explainer. A Java GUI relies on interacting elements built around a core triad. First, we have components. These are your visible UI elements. Second, we have events, the actual user actions, like a mouse click or pressing a key. Third, we have listeners, objects that just sit and wait for those specific events. And finally, helping to keep the whole shebang tidy, we have layout managers, which automatically organize these components inside their containers. This right here is the interactive plumbing and electricity that brings your application to life. I absolutely love this direct definition from the text. A listener is an object that is waiting for an event to occur and that can respond in some way when it does. I like to think of a listener as this invisible brain hiding inside the walls of our digital house. It just sits there, patiently waiting for you to flip a switch so it knows exactly when to turn on the lights. And this brilliantly illustrates that whole concept. When a program is built around a GUI and specifically designed to respond to events from the user, like a button generating an event the second it's pushed, we call that an event-driven program. It's entirely reactive to human interaction. The program literally doesn't move forward until the user tells it to.
Section 4. Inside the MVC architecture, the architectural style.
So, Swing uses the Model View Controller, or MVC pattern. And let me tell you, this is a massive cognitive load reducer for programmers. It essentially separates your application into 3 distinct responsibilities. You've got the model, which handles the raw data. The view manages the visual presentation, literally what the user sees on screen. And the controller handles all the event handling and logic. By keeping these completely separate, your digital house stays incredibly organized and way easier to maintain over time.
If we look at the actual Java class hierarchy, it's like tracing a family tree. Everything in Java descends from a foundational object. From there, we step down to a component, which holds basic visual attributes. A specialized version of that is a container, which does exactly what it sounds like. It groups other components together. And finally, descending from that, we reach J component,
which serves as the superclass for all those modern, lightweight swing elements we were talking about earlier.
Section 5. Building blocks swing components. The materials.
Let's see how this builds our actual interface. Here's a quick structural list of the basic swing components you're going to use constantly. A J-label is for uneditable text or images, kind of like a welcome sign on a door. J-text fields and password fields collect a single line of user input, while a J-text area handles the multi-line text. A J button triggers an action when clicked. A J checkbox lets a user toggle an option on or off, and a J combo box gives you a really nice drop-down list of items. These are the physical, tangible materials you're going to use to construct your rooms. But if you just throw a bunch of buttons and text fields into a window, it's going to look like a cluttered mess. And that's where layout managers come in. These are the objects used to automatically arrange and organize the positions of your raw materials into a cohesive, user-friendly floor plan, which is usually done inside subcontainers like JPanels.
Section 6. How to build your GUI. The construction. Okay, here is the exact sequence to pull this all together. Step 1. Import your required packages like java.awt and javax.swing. Step 2. Instantiate the top-level outer container. Think of this as framing the exterior walls of the house. Step 3. Instantiate your inner containers and add your controls like those buttons and text fields we just looked at. Step 4. Add that inner container to your top-level container. Step 5. Display the top-level container to the user. And finally, Step 6. Ensure you make the GUI thread-safe so the whole thing runs smoothly.
Actually, scratch that, there is one final, absolutely critical act of construction. As the programmer, you must carefully establish the relationship between the listener, the event it listens for, and the component that will generate the event. Basically, you have to physically connect the invisible brain to the light switch using your code. If you don't wire the house properly, well, those buttons just aren't going to do anything when clicked.
And there you have it. We've gone from abstract textbook concepts to a concrete understanding of exactly how Java GUIs operate. You now know how to lay the foundation with Swing, frame the walls with containers, and wire up the electricity using the event-driven triad. So, now that you possess the blueprint and the materials, the only question left to answer is, what kind of interactive world are you going to build with your code? Thanks so much for joining me on this explainer, and happy coding!